Just catching up on some live streaming here, watching One Hand Medic do some Tom Clancy. I'm gonna leave that going though, so he gets the watch time. Let me mute this. All right, today I've got something pretty exciting in store. It's gonna be a fun one. For proof of concept, it's funny what I'm about to say and then I run into this desk. For proof of concept, we're going to build an obstacle avoidance system for wheelchairs. Now, it's not going to be machine vision or anything too insanely technical, but the theory is when you're backing up or potentially going forward, this system is going to stop your chair, maybe as you hit it or hopefully just before you hit it. It's going to be fun to test this, but what we're going to be using is one of these kits for your car. Now, this thing is similar to the backup sensors that they have on a lot of vehicles. It makes a little beeping noise and has this little gauge here. It lights up from green, yellow to red as you get closer to an object you're backing up to. So what I'm going to do is I'm going to hack this thing open with a little controller here, and I don't know if these are ultrasonic or infrared. I think they might be infrared, but we've got all the sensors here. We've got the control module. I'm going to mount this on the chair and then set it up through the alternative switch box or the inputs that a lot of these wheelchairs have. Right, let's see here. Right here, most wheelchairs, this is an RNet controlled permobile, but you have these two little auxiliary jacks that plug in here. They're essentially mono, like 1/4-inch headphone jacks. And those can be programmed to trigger various functions on your chair when a switch is detected. Now, another chair that I have uses that input for moving the seating on the chair. It's my Amy Systems chair. It plugs in via that. But anyways, I'm going to get into this. I'm going to tear this thing apart. And I think without any programming, we should be able to make this work. Most all of these chairs, from the factory, one of those two ports is set up to just turn off the chair. So that's what we're going to do here. You're going to get close to something, this system's going to sense it, and it's going to send out a signal to shut off your chair. Now, obviously not the most ideal situation. It may be an abrupt stop, but I want to do this as proof of concept. This is technology that could be very easily adopted by manufacturers, and the idea here is to show that for 30 bucks and minimal soldering skills, this is doable. So I'm going to tear this apart. I got this kit a while back and I haven't done anything with it. So I'm going to hook it up here on the desk, power it up with the power supply, see how it works, and then figure out a way to do this. But should be pretty simple. Alright, I've got everything sort of laid out here according to the schematic. I've got these 4 sensors taped to the desk. They have left and right sides. I think what I can do is put 2 of them on the front and 2 of them on the back of the chair maybe, assuming we want to stop going forwards and backwards. But we've got our little display hooked up here. We've got this thing plugged in. So let's get this power supply turned on. Okay. Set that to 12 volts and let's power it up and see what it does. Okay, whoop, let me back up. Okay, so it's detecting me as I get closer. And as you can see here, when I move my hand closer, so as I get closer, these things are not exact. Let me back away. Those things need to be aligned a little bit better, but as I get closer to them, in theory it's going to show a different distance. So let me put my hand up here, and as you can see, the closer I get, the quicker it starts beeping. Now, I think the first thing I'm going to do is unhook that beeper because that is super obnoxious, but for proof of concept, the thing seems to work. And we have, let me zoom in here. We have the little green, yellow, and red LEDs. As I get closer, you can see they go from green, yellow to red. And it looks like when I'm maybe 2 feet away is when it goes to red. Okay, so that's maybe a foot or so. Let me shut this off because that's annoying. But I think the way I'm going to work this, I'm going to take apart this little display and I'm going to connect an output to the LED circuitry, and then I'll have it drive a relay, and that relay is what's going to switch the settings on the chair, or basically trigger whatever is programmed in there. Now, it seems to be about a foot or so when it gets to like full stop mode, so we can play with different outputs. I'm going to do an output for green, one for yellow, one for red, and left and right seems to be separate. So like I was saying, we can put one on the front and one on the back. I'll probably just do the rear for right now, just to kind of control things a little bit better. But I'm going to have to get a little metal or wooden plate or something to mount these on and stick them to the chair, because they have to be a certain distance from each other. You can do 2 or 4. Oh, actually, yeah, so it's showing on the manual you can do front and rear if you would like. But the sensors have to be a certain distance from each other and mounted at the same angle and whatnot. So anyways, I'm going to take this thing apart. We're going to solder on some little pigtail leads coming off of this thing. And then essentially all I'm going to have to do is run a little relay. And there's the beeper hole right there. First thing I'm going to do is disconnect that. But yeah, it works like I thought it was going to. So let's take this apart. A pretty basic little setup here. You can see we've got some wires that go over to this beeper here. So the first thing I'm going to do is disconnect those, because this process with all the beeping and everything is going to be pretty unnecessary. Actually, where's my phone? I'll just take a picture of it. I'm going to take a picture of this here just in case I need to reconnect it later. There we go. And we'll just go ahead and remove these 2 wires that go to the beeper. Alright, so we can get rid of that. I want to power this thing up again real quick and just make sure it's still going to function without that beeper installed. It should, but you never know, just to be safe. Okay, yeah. Looks like our little gauge here is still working just fine. Let me get the soldering iron warmed up, and we're going to put a couple of leads on here. So it looks like, yeah, the LEDs are completely encased in epoxy, but I should be able to trace out, let's see here, we've got, actually let me look at that one more time. I need to see how many LEDs are grouped together here. Okay, so we've got 2 green, 3 yellow, 2 red. And it looks like the yellows always come on together, and the greens, I think the green is always on. Okay, I'm actually gonna have to make a little schematic here for this. So let's take a picture of this thing. There we go. And we'll grab our old trusty Apple Pencil here. I have trouble writing with the fine motor function in my hands. I mean, obviously I can do soldering on a lot of stuff, but when I try to write, this case is going to keep me from plugging this in. Oh, battery is low. Okay, we're going to have to charge this Apple Pencil for a few minutes, and then, well, I'll show you what we're doing. Markup, there we go. Okay, so we'll get a red pencil here, then we can draw right on the screen. But, so what we've got is 1 green, and then 3 yellows, and 2 reds. So that's 1, 2, 3, 4 channels, and then center display doesn't matter, so we can just leave that alone. And so we can do this for like rear, front, and then I think it's the same on both sides. Let me just double check here again. Yeah, so it looks like no matter what, we get single green. Okay, so what I'm trying to do is basically, I'm going to pull the power off of the LED circuitry for either yellow or red, and I need to know which of the LED panels are linked. Now obviously this doesn't have 1, 2, 3, 4, 5, 6, 7. It doesn't have 7 levels of sensitivity. I think it has like maybe 3 or 4. But if we look at the back of this, we've got 1, 2, 3, 4, 5, 6. So we'll assume 1 is ground. So 5 levels potentially. And I thought there was 4. So let's see. I think the next step I need to do here is I'm going to get this stuff mounted up on a piece of wood or some sort of something or other to actually hold it straight and level, and then I can continue testing this. Then we'll work on getting our schematic going and go from there. I just can't wait till this gets attached to a chair and we actually do some testing. That's going to be the fun part. Well, had a successful trip to Goodwill Bins. Found a whole bunch of random stuff, but mainly the whole reason I went there was for this little piece of wood. Snap this off a shelf there, but this will be perfect to mount these to, at least for testing purposes. And the kit came with this hole saw, which will work just fine for wood. Again, though, I do not have a drill. Well, I do, but I have that one that doesn't have a charger and the battery's messed up, so maybe I can run it off the power supply. Well, we'll see if we can figure out how to do this. I did manage to find this touchscreen universal remote at Ben's, and I programmed the air conditioner into it. So I can turn it off. I just need to turn off the ice maker. Okay, so remember this thing and this battery that I determined is probably bad? Well, I'm going to try and run this drill with the power supply here. May not be the best idea in the world, but we're going to give it a shot. I'm not sure what the maximum capable amperage is of this thing, so let's see if we can figure that out real quick. To test this, all you do is turn the thing on, and this one you can set the voltage to whatever you want, and then there's a current limiting mode. To set your maximum current, you short the leads together, and then you can adjust the current dial to whatever you want. And it looks like our maximum is about 6.5 amps. So that might be enough to run the drill. Carefuling. Carefuling. Alright, this is when the smoke might come out of the box. Hey, seems to be working. Let me put some load on it and see how much amperage we're pulling. Okay, so it pegs at 6 amps. That might be enough, though, to drill a few holes in this piece of wood. Alright, you ready for some genuine safety to happen? Forward. Oh yeah, we're only pulling 3 amps from the power supply while drilling. Terrible camera angle, I know, but it's this number right here. Hey! Success! Alright. I'm gonna unhook this. Wires are warm but not hot. And I'm gonna go ahead and leave the power supply running just so it can cool down. But in theory now, these should pop right in. I just drilled the first hole without measuring. I'll after I get this one in here and make sure it works, I'll check out the spacing, because these obviously need to be a certain distance from each other. Oh, beautimous. Look at that. Got a nice little sensor right there, pokes through. Ah, this will be perfect. I'm just doing this for a proof of concept. We're not going to be permanently installing this on the chair. So I think this little piece of wood might be good, because I can just mount this to whatever surface we're going to be testing this with. But yeah, anyways, I'm gonna get the rest of these holes drilled here and try not to overheat the old power supply, and then I'll be back. All right, there we go. I'm gonna clean this up, and then it is possible to run this thing with just 2 channels or 2 sensors, so we'll do that now, and then check to see what our LED situation is like here. It appears as though when it doesn't see anything, there's nothing on the screen, and then as we get closer, our numbers start to change and the little bars go up. Where my hand is right here is about the maximum distance, which we need to test and see what the stopping rate of a power chair is at various speeds, but I think for now that closest setting should be about good. We can adjust it later. The only thing I'm worrying about is false triggering, and if you're running around inside of a building, you might get that close to a wall. So there's a little bit more that's going to go into this, but like I was saying, just for proof of concept, we're going to install this and just test it in a wide open space. I think I might, yeah, I'll put it on the front or back or something, I'm not sure exactly, but I think I'm going to pull it off. I'm going to pull the signal off of this, yeah, I'm going to pull the signal off this last red LED here, I think. I think that's going to get us the signal that we want to use, at least for testing for right now. Okay, I think I've found the pin that's responsible for that last light. It jumps from 0.5 volt to 1.7 volts when I wave my hand over it. As you can see, when I put my hand over the top, that last one turns on. So we're going to pull our signal off of that line. Time to get to soldering. Alright, well, we need to go to Fry's Electronics. I wasn't able to get those relays that I wanted for the obstacle avoidance system, and I really want to get that done today. So, I'm going to grab the GoPro, and we're going to go down to Fry's Electronicals. I know I've mentioned this before, but you know those days where you just feel like extra disabled, and everything you do seems to involve things falling on the floor or stuff breaking or getting hung up in doorways and whatnot. It might coincide with not getting enough sleep, although that's kind of a weird concept as well. I was in bed for 9 hours last night, but I still feel like I got like 2 hours of sleep. Anyways, I don't know why I said all that other than to say some days are annoying. All right, let's go to Fry's and get some parts, and then try to crash a wheelchair into a wall. I did it again. I've just bought coffee at McDonald's, but check it out. I already had coffee and like a decent amount of it. No, I'm not an addict, I swear. So, set the video light to 100%. Okay, we have some stuff. Now, to make this project work, oh man, things are getting a little bit cluttered in here. I needed a few parts, one of which was a different iron to go on my soldering station. That one's got some sort of issue, and when you turn up the temperature all the way, it tends to burn up the tip, and yeah. Oh, also the cord on it is this like non-flexible material, and anytime I grab the soldering iron and move it over here, it winds up ripping stuff off the desk. So this is an actual name brand Weller one that I should be able to just plug. I just realized. So I had two of those soldering stations. One of them has a removable cord, this one does not. As you can see, it just goes straight into the side of the thing. The other soldering station I have, there's an outlet, and you can just swap this out, and then the dial allows you to change the heat settings and whatnot. But this one doesn't have that, so whatever. But I needed some little relays, like little tiny ones. The signal that comes off of that little board is anywhere between 1 and 3 volts. So I got a 3-volt relay and a 6-volt relay. Now the reason I got the 6-volt one is because there is some residual voltage, like 0.7 volts or something, which may trigger the 3-volt one depending on the brand. A lot of these are rated at different voltages, but they will trigger at a lower voltage. So I got a 6-volt one as well, just in case the bleed through voltage, well, whatever. I gave myself 2 options. But the way this little display is set up, I can't see under the circuit board. Now I did use my meter and try to figure out which pin was which. I think I know what it is. But I can see the traces through the epoxy. So I'm gonna have to desolder this little board and pull it off so I can verify which traces are the ones I actually want to use. And I couldn't find my soldering, I've got a desoldering tool, it's a big spring-loaded thing, and I also couldn't find the wick, so I just got some more solder wick. But I guess I'm gonna clean a little bit of this up, get the new soldering iron plugged in there, and get to work on this. And I think this should be everything we need. In theory, once this relay works, I can set it to a different LED to adjust the distance, and when it trips the relay, we'll use this to interface with the wheelchair to make it stop. All right. Doesn't really fit in there very well. Although, it seems to lay on the table without touching. I'll just have to clean off all this stuff and be careful. Make sure I don't lay my arm on it or something like that. It has this weird little stand, which, I don't know, something I guess, but anyways. Ooh, it has LED lights. Fancy. Whew. Just burnt my finger. A little singeing action. Luckily I didn't feel that. There we go. You should be able to see. Yeah. See, now we can follow all the traces in here and figure out exactly which one of these pins are the ones we want to use. But first, I'm going to unplug this soldering iron because it is stupid hot, and I don't want to burn myself and everything else around here. So we'll put a protective layer of solder on here. There we go. And unplug. Okay, I'm gonna get a little, I'm gonna get this relay set up with some wires on it so we can back probe some of this. Actually, I may not even need to use this display. I could probably just pull it right off of here. Let's see here, coil, sweet, should be easy enough. Got some hookup wire here. Oh, dang it, I accidentally bought solid core wire. Oh well, it'll still work. Now with relay coils, polarity does not matter, so that's why I'm making both of the wires black. Coils don't have a positive or negative, so any way you get the power to them is just fine. Alright. Let me get the rest of this here and powered up and see what we can figure out. Okay, I've switched over to the smaller soldering tip. The other one was way too big. I think I might have overheated this little board. When I power the thing on now, nothing happens. But I did check with the voltmeter, and we are getting power to the output pins. So that's something. I was gonna see if that little beeper module was still here on the desk and hook that up just to see if it's doing anything. Just by the off chance that here we go, that I maybe blew out the LED driver portion. I don't remember where that was connected. I think I took a picture of it with my phone. And that's why you take pictures of things. Oop, soldering iron. That's why you take pictures of things. You can figure out where the connectors are supposed to go. Hey, okay, so it's still alive. I've got the little board with the sensors just sitting here on the floor. I noticed at one point I had knocked one of the... Stop that. That I'd knocked one of the resistors off of this little board, but I was able to reattach it. It was this little top one right here. But as you can see, the board's a little bit burned because the tip I had on the soldering iron was a little bit large. So maybe plan B here. I could potentially use the output of this beeper. I wonder how many volts this runs on. So that's outputting 12 volts. Let me think about this. We can make it work somehow, I know. What am I doing? I have this microscope thing here. I'm like straining to read stuff, and I just realized I have this thing set up exactly for this purpose. Oh, that's funny. Oh, I think I unplugged the TV. Okay, a number of hours have passed. I've been diligently working away at this. I might have found a solution. I've been rummaging through all my stuff trying to find a 12-volt relay, and I found one on this bank of relays that was... This was for the old remote start system on the green van. But the control module got damaged somehow, so we're not going to be using this anymore. But 12-volt relay, I think we can make something work here now. I found an auxiliary output on this little board, and I think, well, it's outputting 10 volts, so in theory we should be able to pull or use that to trigger this little relay. Let's solder some stuff on here and see if this will light something on fire. Okay. I wound up hanging the soldering iron from the ceiling and connecting it to a smart switch so I can tell the Amazon Echo to turn it on and off. That may seem dangerous, but it's not going to get in the way and I'm not going to burn myself with it like that. So the voltage changes. I'm moving my hand up and down, but the voltage changes as it's, well, let me just hook this up. Now the one thing that could be going on is this is showing a lower voltage because it's pulsing. We're going to find out here. Yeah, it's pulsing. Listen carefully. I can still make this work for proof of concept, but we're gonna have like 3 meters of space. So if you get within 3 meters of a wall, it's gonna stop your chair. There is ways to take care of this, but I'd have to buy more parts and it would take more time. So I'm just gonna wire this up as is, and then we'll show you proof of concept. And again, I'm gonna be poaching parts from another project. That seems to be kind of a way of the times, but this thing is already set up to output 12 volts, and this light setup on this chair kind of needs to be changed anyways, so we're gonna use this, and we're gonna wrap up this project here. I'm gonna get it all put on a chair. I'm gonna head downstairs to the parking garage, although it's rush hour now, so probably shouldn't go down there. But anyways, I'm gonna get it all buttoned up. When I come back, I will show you the functioning prototype. Okay, I won't say this project turned into a train wreck, but it prevented a couple more challenges than I was expecting. I thought this display would be a little bit different than it is, but they went through extreme lengths to not spend money on things. And the idea was to just pull signal off the one red bar, but you can't do that. So what we have here is a piece of wood from a shelf that I got from Goodwill bins. We've got our two sensors mounted to it. And around on back, we have the rat's nest that will control the whole system. Then we have an output that plugs into the chair, and that will basically take control and stop the chair when needed. And the whole thing's run off of a USB cell phone power bank. So, I'm basically just gonna hold this thing on my lap in front of me, plug it into the chair, power it up with this, and then we'll try to smash into a wall and see what happens. All right, so the way I'm gonna work this for now is I'm basically just gonna hold this thing right here on my lap, and then I'll plug in the interface to the chair, and in theory, when I come towards this wall, it should stop me. Got the other camera down here, so you've got another angle, and see what happens. So the interface is plugged into the chair. Let's go ahead and power up the system here. There we go. And you can hear the clicking and the beeper there. But in theory, I just need to hold this straight, and then it should stop me before hitting that wall. And the way this is set up right now, it's something that would need to be changed later, but I have to actually unhook it from the chair because there's no way to reset it and allow you to move away from the wall. So I'm just gonna go forward here. And there we go, it stopped. And there we go, it stopped. And unplug it. And you can see we're a little ways away. Let me try that again here. We'll back up. And turn it back on. Okay. So I have to unhook it, then we can back up. Unhook it, then we can back up. But yeah, it seems to work. If I'm going too fast, obviously we'll hit the wall, but yeah, I mean, you get the idea. Now, the problem with this, obviously, is like trying to go down hallways or going through doors or things like that. Originally, I was thinking I could put it on the back of the chair for backing up. But like I said, there's a little bit more that needs to be involved. And also, after it stops you, some sort of feedback that will let you move again. But I just thought it was kind of an interesting thing to try out and see if it's going to work. And it seems to. Now, trying to get through this door, it's not going to allow that to happen because I'm too close. So we'll turn it off here to get through the door. Go ahead and turn it back on. Let's see if we can get around this stuff here. Oop. Okay, that was just something fun to test out. Like I said, it's got a lot of issues, and it definitely needs, well, there's limitations with this type of system. Now, obviously, like on drones, like DJI uses, they have a whole bunch of sensors. They have machine vision that's like looking at a bunch of stuff. These, I believe, are just infrared. They're not ultrasonic. But, yeah, I mean, there's something to this. So the other thought I was having to use this for was to put a couple of sensors. It actually wouldn't need to be this this elaborate. It can be a lot smaller. They actually have little distance sensors that are built into a single module. But I was thinking about putting a little light up sign on the back of the chair or something like that that says warning, serious bodily injury, you know, keep back 5 feet or something like that when someone comes up and stands right behind you. But then that kind of attracts more attention than I think I want. But anyways, so yeah, there you go. Cheapo vehicle parking thing. Actually got this at Goodwill for like $12 a year ago, and it's just been sitting around. Figured I'd use it for something, but oh, and in case you're wondering, the way I'm stopping the chair is I'm taking advantage of the inhibitor when you plug in your chair to charge it. And even if you're moving, that will just completely stop your chair. So that's what's going on here. It's a ridiculously simple setup. This chair, I had to change the programming on it though, because some chairs, when you plug in your charger and the chair is on, and then you unplug it, you have to power cycle the chair before it'll move again. That is a setting that you can change though, and on this one I did change that setting. So the second you unplug the charger, even without power cycling the chair, it lets you move again. I've tested out things like this on various different chairs. Some have that latching mode enabled and others don't, which is different from latch driving, like with head arrays and whatnot, but yeah. And stuff like this could be used for other projects. Like, I've got a number of, well, I built a remote control leaf blower like a long time ago. It was like, I don't know, the first month of like vlogging I was doing. But something like this might be handy for a little autonomous thing for someone that walks past in front of it. And we could set the sensor range a little bit shorter, since the remote control stuff isn't going to be moving at a ridiculous rate of speed, but it could potentially be useful for something like that. Now, obviously going to cost a lot more money, but it would be cool to play around with machine vision. That's going to require a little bit of coding, or potentially taking apart one of the quadcopters that has obstacle avoidance and retrofitting that whole setup. Now, Segway, or Ninebot as they're called now, they have... I did another video actually a long time ago, well, maybe a year ago, about the Segway transporter. It's a little miniature thing, the Mini Pro I think it was. But they sell a basket you can put on that, and you have a remote control. You hold the remote, and the thing will follow you around. I was thinking it'd be cool for carrying groceries or boxes or stuff like that. That first version wasn't extremely well suited and didn't have any obstacle avoidance stuff whatsoever. It was mostly designed to just have the thing follow you around if you're out in a large open area. But they have another version of it now. I forget what it's called, but it actually has cameras and machine vision and all that stuff. So it can actually follow you around and you don't have to hold that little remote. So the technology's out there. It's getting better and better. But I think there's just a lot of applications for this stuff that could be utilized to help out people in situations like we're in, where you can't walk. I mean, how cool would it be to have a little shopping cart, out of a lack of a better term, following you around with all your stuff in it, right? There you go. I wouldn't say a pointless project, but it's definitely random.